Hi guys, welcome to the final part of lesson 2.7 using formulas. Our objective for today is still that I can solve equations for specific variables and that I can convert units of measure. Today we're going to focus on the final element of our vocabulary, the dimensional analysis or unit analysis, and that is the process of performing operations with units. So we're going to pick up where we left off yesterday on example number 5. And example number 5, we're going to be converting with different units. So first off, we're told if 1 gallon is equal to 3.785 liters, how many gallons of water are in a pool that holds 97,285 liters? Well, we're going to start with two things. First of all, here's our starting point, because that's what our reference is. How many gallons of water are in a pool that holds that many liters? So how many gallons? Gallons is what we want to get to in the end. And lastly, we have our exchange rate or our ratio, and it's that 1 gallon is equal to 3.785 liters. Now, when we go ahead and start converting this, we are going to get some things. So let's start. We've got 97,285. So that's 285 liters. That's what we're starting with. And that's over 1 because it's over 1. We don't have anything else with it. So now we're going to go ahead and convert. And we've got a ratio here. And what we want to do, we want gallons. So we want that to be in the numerator. So in the end, we want gallons to be in the numerator, and we want to cancel out liters. So gallons, 1 gallon is going to be equal to 3.785 liters. Okay, and we are multiplying here. And that's our conversion, right? Because once we do this, liters cancel out, and I'm only left with gallons as my unit. There's no other units anywhere else in this problem. So when we multiply fractions, we start by multiplying straight across the numerator. So 97,285 times 1 is 97,285. And we have 1 times 3.78, and that's 3.785. And now we go ahead and use our calculators to do the division on this one, and we are going to get 25,702.77 gallons. So in a pool that holds 97,285 liters, that would convert to holding 25,702.77 gallons. Now, if we look at letter B, if 100 centimeters is equal to 1 meter, how many meters is 1,250 centimeters? So we start off with what we know. 1250 centimeters is what we are starting with, right? That's what we are comparing to. And we have our ratio here that we're going to use to convert. So we start with 1250 centimeters over just 1, right? Because any whole number over 1 is a value over 1. And now we need to include our conversion factor. And we know that 100 centimeters needs to go in the denominator because that's the only way we can get our units to cancel out. If 1 is in the numerator, 1's in the denominator, we're dividing centimeters by centimeters. And this is equal to 1 meter. All right, so now we're going to go ahead and we are going to solve this. So we multiply straight across. We have 1250 over 100. Our centimeters cancel out, and that's going to simplify to what? We're going to divide 1250 by 100, and we get 12.5 meters, because meters was the only unit that was left. All right, now we're going to go ahead and look at letter C. This is a you-try problem, so please try this one and letter D on your own, and then we will go over them with my work. So if 1,000 grams is 1 kilogram, how many grams are 23 kilograms? So we're going to start with 23 kilograms over 1. And as you do this work, I encourage you to be showing your work exactly how I am and lining up your units so that they cancel out. So again, we have 1,000 grams per 1 kilogram. So now we just need to multiply straight across. Our kilograms cancel out because there's 1 in the numerator, 1 in the denominator. So 23 times 1,000 is 23,000. And that is measured in grams. So 23,000 grams in 23 kilos. Now, letter D, we're going to convert 1 yard, if 1 yard is equal to 3 feet, we are going to find out how many yards are there in 90 feet. Now, that's the distance between first base and second base, 90 feet, or any base from one base to the next in baseball. So we start off with 90 feet is our starting value, and it's over 1. And we're going to multiply by our conversion factor, which is that 1 yard is 3 feet. So our first step is going to be to multiply straight across. So 90 times 1 is 90. 3 times 1 is 3. The feet cancel out, and we are just left with yards. And so 90 divided by 3 is 30 yards. So the distance from first base to second base is 30 yards. All right. Now, in example 6, we're going to use dimensional analysis to convert units from one system to another. So, for example, here we have pictured at the right One World Trade Center, and it is symbolically built to be 1,776 feet tall. And we want to know how many meters tall is it. Now, I hope you all understand why it is 1,776 feet. 1776, Declaration of Independence, all of that good stuff. History of America right there. So, 1,776 feet tall, that's what we're going to start with. And we're given a conversion factor of 1 meter is 3.28 feet. So we start with 1776 feet over 1. And we are going to multiply that by our conversion factor, which is that 1 meter, the unit that we want to end with, is 3.28 feet. So now it's time for the multiplication. We go straight across. 1776 times 1 is 1776. 1 times 3.28 is 3.28. Our feet cancel out, and we're left with meters. And so when we do the division, 1776 divided by 3.28, we get a 541.46 meter tall building. Certainly less symbolic of a value than 1776 when it comes to Americans and American history and American culture. And there you have a picture of One World Trade Center in the center. And then you also have the 2 footprints and of the original Twin Towers, along with the 9/11 Museum. And so we have some other trade buildings here, and here's the Hudson River along this edge. So just giving you a little bit of a landmark and reference point to South Manhattan there. All right, so let's go to the next page, and we've got exchange rates on currency change daily. As of a couple days ago, $1 United States or currency, the $1 American, is equal to 1.35 Canadian. And we want to know how many Canadian dollars can I get for 250 American. So we're going to start off with, we have 250 American dollars. That's our starting point. That's what I know I have. And we're going to use our conversion factor of $1 is equal to 135 Canadian. So we start with 250, and we're going to put dollars there over 1. And we are going to multiply that by our conversion factor, which is $1 is 1.35, and we'll just write dollars can. So dollars Canadian, and that's going to equal, so we're going to multiply straight across. 2.5 times 1.35, that's going to give us, 250 times 1.35, it's going to give us $337.50 Canadian. Okay, because the American dollar sign cancels out, and we're left with dollars Canadian. Now, interestingly enough, the Canadians do not use paper bills for $1 denominations. They have a $1 coin, and it has a loon on it. So they call it a loonie. And then they have a $2 coin that they call a toonie. Interesting little, cultural fact about our neighbors to the north, America's hat. All right, so we have 2 problems here for you to try. The first is the Hubble Space Telescope weighs 24,500 pounds. What is its weight in kilograms, given that 0.454 kilograms is 1 pound? And convert 525,600 minutes into years. Check your work and then come back, or do it and then come back and check your work with me. All right, so for the first one, 24,500 pounds. This is our starting value, and we have its conversion factor. 0.454 kilograms is equal to 1 pound. So we start with 24,500 pounds, and that's over 1. You'll see why we include everything as a fraction when we start talking about the next section. And we're multiplying by, we have 0.454 kilograms for every 1 pound. So when we do this math straight across, first off, our units, the pounds cancel out, and we're going to do 24,500 times 0.454 kilograms, and we are going to get 11,123 kilograms for the Hubble Space Telescope. Now, this was launched in the 90s, and at first it was a colossal failure. We will talk about that a whole lot more when we start talking about our optics and light unit in science class. Needless to say, after several repairs, Hubble Space Telescope has provided some incredibly beautiful pictures of the universe and expanded the science that we can do. All right, now, letter D, we are going to convert 525,600 minutes into years. So here, we're only given a starting point, and we're given an ending point. So we're going from minutes to years, and we need to figure out the steps along the way. Now, the reason I didn't give you any conversion factors here is simply because you should be able to know all the conversions between minutes and years. You're in middle school. So we start with 525,600 minutes is over 1. So the first unit I'm going to convert, I'm going to go from minutes to hours. So we have 1 hour is 60 minutes. All right, so our minutes cancel out and I'm left with hours. Do I want hours? No, I don't. I want years. So I need to go again. I need to try again. I'm going from hours, so 1 hour, well, I know that there are 24 hours in 1 day. So we have 1 day and 24 hours. Okay, so hours, again, those two cancel out. So now I'm left with days. Still not where I want to be yet. So I do know, in fact, that 1 year is going to be 365 days. And again, day cancels out, and now we can do our multiplication. So we're going to multiply straight across the numerator. 525,600 times 1 times 1 times 1. So that's just going to stay 525,600. And we are going to divide that by 1 times 60 times 24 times 365. That is going to give us 525,600. And 525,600 divided by 525,600 is 1 year. Year is the only unit that remains. And if those of you who are out there watching this are fans of the musical Rent, you would already know that 525,600 minutes is how we measure a year. All right. Now, we're going to use dimensional analysis to convert rates. So rates are going to have a numerator and a denominator when we start them. So we have an athlete is running a sprint of 100 feet in 3.1 seconds. 100 feet in 3.1 seconds. At what speed was the person running in miles per hour? Okay, again, we're not giving conversion factors here. We're just being told to convert these units. So we are going a rate of 100 feet per 3 seconds. 3.1 seconds. Now you can see why I've been writing these all as fractions all along. So 100 feet over 3.1 seconds. Well, you know what? I really would like to convert, I would like to change the seconds and get that into our hours first. So I'm going to convert. And I know if I have seconds in my denominator, I need seconds in my numerator. So that would put minutes in my denominator. So seconds, this way we put the units in opposite parts of the fraction so that they can cancel out. So I know there's 60 seconds in 1 minute. I also know that there are 60 minutes in 1 hour. So now, as we've gone through here, my seconds have canceled out. Okay, my minutes have canceled out. So now I have feet per hour if I'm just looking at my units. Not quite where I want to be, so we can keep working. We have feet per hour and we want to be in miles per hour. So that means you need to use the conversion factor for miles, which is that 1 mile is equal to 5,280 feet. All right, so now again, my feet have now canceled out, and I have miles as the only unit in my numerator. Okay, miles in my numerator and hours in my denominator. Everything else to this point has canceled out. So now we need to do our multiplication straight across. 100 times 60 times 60 is going to be 360,000. Over 3.1 times 1 times 1 times 5,280 is 16,368. And now you're going to go ahead and do that division on your calculator, and you are going to get an answer of 21.99 miles per hour, or mph, miles per hour. Okay. Now, letter B, we have a student running 100 yards in 12 seconds. 100 yards in 12 seconds. At what speed did the student run in miles per hour? So we're going to start off with 100 yards over 12 seconds. Now, we just did this conversion up above, specifically this part right here, this 60 seconds to minutes, 60 minutes to hours. So what I could say for this is, well, 60 times 60, 6 times 6 is 36, plus 2 zeros is 3,600. So I'm going to use the conversion factor that 3,600 seconds is equal to 1 hour. So I just took this piece right there and multiplied it and brought it down there. Okay, so just that piece right there. Now, we have seconds canceling out, and so now I have yards per hour. Well, I don't know a clean conversion from yards to miles, but I could use that 3 feet is 1 yard. And then I could also now use the fact that 1 mile is equal to 5,280 feet. So feet are going to cancel out. The yards canceled out. And so now I'm left with multiplying straight across my numerator because my values, my units are correct now. I have miles and I have hours, the two that I wanted. So 100 times 3,600 times 3 times 1 is going to be 1,080,000. 1,080,000 over 63,360. And then when you do that division, you get that the student ran 17.05 miles per hour. A somewhat unbelievable speed. All right, now there are 2 U-Try problems, one involving Aroldis Chapman and one involving the SR-71 Blackbird. Go ahead and try those on your own. So, if we're looking at the first problem, Aroldis Chapman holds the record for the fastest recorded pitch in Major League Baseball at 105.1 miles per hour. What is the speed in feet per second? So, we are starting with 105.1 miles per 1 hour. Okay, now we're going to convert kind of backwards of what we've done recently. So I know that conversion we're trying to get to feet per second. That's our goal. So we need seconds in our denominator. Well, I know 1 hour is 3,600 seconds. So hours cancel out. So now I have miles per second. Well, hey, we've got part of our units right. We've got the seconds that we're looking for, but the miles isn't what we're looking for. So I need to convert miles into feet. So this is, again, 5,280 feet is 1 mile. Okay, so now that seems to be what I want, right? So miles cancel out, and hey, look, I'm left with feet, which is what I wanted. So now we go ahead and we multiply. 105.1 times 1 times 5,280 is going to give us 554,928 over 3,600. And when we do that division, we get that it's 154.15 feet per second. Now, if you didn't know, the distance from home plate to the pitcher's mound is 60 feet, 6 inches. So 60.5 feet. So that means in less than half a second, Aroldis Chapman's fastest pitch went from his hand to the catcher's glove. Less than half a second. All right. So we have now the SR-71 Blackbird, and it is the world record that we know of for the fastest air-breathing manned aircraft since 1976 at 3,529.6 kilometers per hour. That is our starting point. What is its speed in meters per second? So let's look at this. We have 3,529.6 kilometers per hour. And we are trying to get meters per second. So I'm going to start with converting time. I always seem to like to convert time first. So time, we know that 1 hour is 3,600 seconds. So my hours canceled out. And now I'm going to convert my distance. I know that 1,000 meters is 1 kilometer. And now, again, my kilometers cancel. My 2 units that I'm looking for, I have seconds in the denominator. I have meters in my numerator. So I can multiply straight across. 3,529.6 times 1,000 is going to be 3,529,600. So 3,529,600 over 3,600 times 1 is 3,600. And this is going to equal 980.4 meters per second. And that's 0.4 repeating. All right. Now, so give you perspective, that's almost an entire kilometer every second. That is a incredible speed. So those of you who run track, the 400 relay, right? All those laps around the track, this can do it over 2 times, more than 2 4x100 relays in 1 second. And here's a picture of the SR-71 Blackbird as it sits displayed in the Udvar-Hazy Center. This is a branch of the Smithsonian Institution in Washington, D.C. And actually, way back here in the background, you can see the Space Shuttle Enterprise. This was an atmospheric test vehicle, and yes, it was named after the Enterprise from Star Trek. So if you're ever in Washington, D.C., I highly encourage visiting the Udvar-Hazy Center. They also have a lot of other famous aircraft, including the Enola Gay, which is the plane that dropped the atomic bomb on Hiroshima. So that is our notes for Module 2.7. This is also the end of our notes for Module 2, so we'll be working on the test coming up. If you have any questions, please bring them to class. Otherwise, have